Isaac Newton was a very successful academic, as you know. He is the person who uh, did a lot of contributions to physics, to calculus, and to um, optics. He was actually elected member of the Royal Society for his contribution of how to polish the lenses for telescopes, for example. But a less known fact is that Isaac Newton was a government employee. At some point, he decided to give up his academic career, and he started to work for the Royal Mint, organization that prints money. And what was happening those days in England, English coins were worth less as currency in England than precious metal in Europe. And there was a large variability in the weight of coins, which made it hard to stop clipping. So let me explain what it means. If you take a coin, and those coins were produced in there was a lot of manual steps during the production of the coin, and those a lot of manual steps led to a lot of imprecisions in the weight of the coin. So some of the coins were heavier than norm, and some coins were a little bit below the norm. So the norm was 100 grams for the coin. Let's say it's a silver coin. And what happens is, so let's say you get a coin, and you put it on a scale, and the coin is 103 grams. But you know that some other coins is 98 grams or 95 grams. Well, you say, okay, if this coin will have the same value as the other coin that has 95 grams, so what I'm gonna do, I'm gonna clip a piece of the heavier coin, and then I'm gonna sell it, and we'll keep using the coin as is, and we'll basically benefit by selling the precious metal part of the coin. So this coin clipping was a huge issue. Some estimate says that 15% of the precious metal that contained in coins were clipped. So imagine basically 15% of your currency was gone. Somebody clipped it and sold it on the black market in other countries in Europe. So Isaac Newton became the came to the Royal Mint when that was a huge problem in England, and it actually caused a lot of the financial problems. But there was a quality control procedure in place, and it was called Trial of the Peaks, and it was held by Newton when he was there to check whether the coins are good or bad. And it's a very traditional English procedure. It's a large hall, and the Newton would preside, and he would sit at his chair, and a huge box full of those coins would be brought into the room. They put it on scales, then they announce what is the weight of this box, and then they decide whether coins that are inside this box good or not. So they would have 2,500 coins in the box. 2,500 coins in the box. And each coin is 100 grams. And the standard those days was the quality. The coin was considered to be coin of good quality if the actual weight of the coin was plus minus 1 gram. So coin is good quality. If the weight is 100 grams plus minus 1 gram. Okay. So again, there was a lot of imprecisions in how those coins were produced. So plus minus 1 grams was considered to be acceptable variation in the weight of the coin. And so they would put those coins on the scale, and they would announce the weight, and you would have, and then they will make conclusion about the quality of all of those 2,500 coins by weighing this big box of coins. Okay. And so you put it on a scale, and let's say you see 25 07. 2507. And the question is, does it mean that the coins inside the box are good coins or not the good coins? Okay. And you know, if we know that each of them should be plus minus 1 gram, then what kind of variations we should expect on the total weight of all of the coins if we put them on scale? Okay. Well, that's not a trivial answer. And actually, even Newton himself, as smart as he is, he didn't get the answer correctly. So when he was responsible for this trial of peaks, the procedure was not done correctly, and essentially the assumption was made that if you allow 1 gram in precision in the weight of each of the coins, then the set of those coins, the average weight, also should be plus or minus 1 gram. So in other words, if you take those all of those 2,500 coins and you put them on scale, and you take the weight of those 2,500 coins and you divide it by n, by the number of coins, then they say, okay, it has to be 100 plus minus or 1. And if this is the case, then we claim that the coins are of good quality and we release them, which was a big mistake. And this is actually the mistake that led to all of those coin clippings, because the coins that were in the box, even though they passed this test, are not necessarily the coins. So this does not mean, so from this one it doesn't follow that each coin is plus minus 1 gram. So this is not the correct conclusion. In fact, the variability of the average weight of the coin is variability of a single measurement divided by the square root of the sample size. And we will see this phenomena many times, and we'll build some intuition around this phenomena. So if you have variability of the single measurement to be 1, and you have 2,500 coins, then this one has to be the deviations in the average weight of the coin if you want to make a conclusion that all of the coins are good, which is this number is 0.02. 0.02. So rather than allowing deviation for 1 gram in the entire box on average, they should have allowed only deviation of 0.02 grams. And if you think about this, what happens is some coins are slightly heavier than 100 grams, some coins are slightly lighter than 100 grams. So you have these cancellations of ups and downs, and this cancellation of ups and downs lead to this smaller variability in the average compared to the variability of a single measurement.